Thank you, everyone, for joining my session. Today, I'm going to talk to you all a little bit about osquery and then using that in the case where you actually don't have it deployed and you actually need it to try and investigate a breach or investigate an incident. Now, to give you a little bit of context on why I kind of landed with this presentation and why I kind of got to this stage with wanting to talk about osquery. A little bit about my background is I currently work for a company called Yara, pretty well known in the US and the UK, and I've been asked to lead the DFIR side of the practice out here in Asia Pacific. And the reason why osquery and kind of using it in sort of this firefighting mode all of a sudden became interesting to me is because I'd spent a lot of time using things like osquery inside an organization. So for many years, I'd kind of spent time using internal EDR tools, internal forensics tools, internal e-discovery tools, and I ended up taking this role to go back and consult and actually go back and actually assist other organizations or multiple organizations. And I wanted to take this approach of being able to use these really interesting and really flexible tooling and telemetry items that I kind of had found and kind of used internally and try to use that back on the consulting side. And I thought, what better place to kind of talk about it at than where we are today at the osquery at Scale conference. Now, this is a little bit of a talk on some challenges that I've run into with using osquery in this way, and also some hints around how to potentially use it in this manner as well. Also, as some of you may know, I'm also an instructor for SANS, in also the advanced forensics and also the network forensics classes as well. So how did I kind of get to this stage with wanting to be able to talk about osquery and using this in sort of this rapid firefighting mode? Well, if we look at how things like osquery is traditionally employed, we kind of have this nice life cycle of being able to do things like understand what an internal organization's needs are and try to determine what the incident response team need, try to determine what the operations team needs in terms of telemetry or visibility with things like osquery. We usually do things like build a deployment and build up a backend to capture a lot of that data and build up all of our configurations to be able to use it and build up things like pipelines to be able to ship data from one location to another location. Often we do things like test the rollout for it, make sure it actually works in the manner that we expect it to, then do sort of a full deployment, and then use it for investigations or incidents as they kind of come up after that full deployment has been rolled out. And then obviously what we would commonly do in an internal organization is start to do things like tune that configuration post-incident. So when we discover that, hey, it'd be really good if osquery was doing this differently, or it'd be really good if we had certain tables doing snapshots and shipping them at different rates, we can kind of tune all that after investigation works. And this works really nicely if you've got an internal organization and you've got time to plan this out and you have buy-in from your networks team and your endpoint management team to kind of get all of this set up and ready to go. But often when it comes to the case of doing things like consulting, you often come in at the point where you have no ability to kind of do this phase rollout or this testing, and you're actually at the point of where the incident has already occurred. And this is usually, particularly in incident response, this is usually where, as a consultant, you get engaged. The incident actually took place a number of minutes, hours, days, or weeks ago. And now you're at this point of going, all right, well, the incident has already occurred. Now, what do I do with something like osquery to be able to give me telemetry and to be able to be useful from an investigation point of view? And it was this approach that I kind of came into looking at osquery in trying to take it from this sort of lovely planned out perspective of how we do it internally to now actually being able to make it useful from a consulting or sort of this rapid fire mode. And the reality is this would kind of apply not just for consulting, but also in cases where if you are an internal team, you might have acquisitions where you don't know what the state of that acquisition or that network might be. It may already be in a state of potentially compromised. And so even some of the things I'll talk to you today about will hopefully apply and hopefully help you with some of those items as well. So to start off with, some of the challenges, particularly with using osquery and doing it in this manner where essentially the incident has already occurred. Some of the big challenges we kind of face are things like, how do we actually determine what the needs are for an incident response team or our forensics team? And the reality is this changes depending on what type of forensics case or incident response case you're actually working on. So for example, if you're working on something like a ransomware case, that is very different to something like an insider threat case. Because in a ransomware case, a lot of the sort of damage that's been done as part of the incident has all happened very quickly and before you actually got there, or before a client or before the owner of the network has actually engaged you. And the requirements of what you actually need to gather and what you need to collect as part of incident response change depending on if this is a ransomware case, to try and determine what type of ransomware case this, what type of ransomware variant it is, or what type of threat actor group may be behind it. Was any data exfilled or not as part of it? And then also, how did the actors initially get into the environment? And again, remember, this has all occurred before you actually get there with osquery to be able to deploy it out. Versus something like an inside threat case where it actually might be quite a slow moving case where you actually need to slowly go through and comb through evidence to actually understand what a particular insider has done. Or you may have sort of this small piece of detail where a competitor has picked up information about your organization and is potentially using that. And now you actually need to kind of backtrack around where that information was and who touched it and where it was accessed. And again, you're looking backwards in time as part of this. This could have occurred. Usually ransomware cases are pretty quick. Usually a client's going to kind of call you and know about that very quickly. But something like insider threat, that could have occurred months ago in the past, where the theft of intellectual property may have actually occurred. And so you kind of have to really stretch your timeline backwards to be able to do that, or to try and scope the machines that might be in scope as part of that. And then again, even something like APT or advanced persistent threat or nation state type threat actor is again very different as well. Again, also has occurred usually a long time in the past. A lot of the statistics show us that is sort of multiple weeks and sometimes months in the past, where again, you're trying to roll back that clock and try to figure out, all right, how did the threat actor actually get in? What did they do once they were inside, and what did they take, if anything, or what have they changed once they got inside the network? Now, I mentioned those, and there are other kind of different variations on those as well, but I mentioned those because they all have very different types of evidence gathering requirements. If it's an insider threat, I actually might want to know things like what web pages someone browsed to. If it's ransomware, I might want to know what applications got executed, and looking at things like shimcache and mcache type information on a Windows system to figure out what was executed at what point in time. And then maybe trying to understand what data might have been exfilled by looking at things like the SHRM database as well. So they all have slightly different components around what type of artifacts you actually want to gather. Now, this is important because you need to kind of understand what artifacts you may want so that you know how things like configurations for osquery are set up, and what type of data you want to prioritize in terms of the capture of data from the osquery agent side, so that you actually have that data back to be able to investigate that as that data is getting shipped out of the environment, or as that data is getting shipped to a central logging platform for you as an investigator to start to look through those. So that's probably our first big challenge that we need to kind of understand and be able to deal with. The next one is how do you make sure that this deployment is ready to go? Because as I said, in the case of something like ransomware, or even when a victim detects a potential APT threat actor inside their environment, often they are right in the middle of firefighting mode and they want things done fast. You don't have a month to kind of let a threat actor continue to wander around inside an environment while you start to build up and slowly deploy osquery out to the actual client as part of that. So as much as possible, you need to do things like make sure you have infrastructure built and ready to go. Like, do you actually have a centralized logging platform that the agents, once you deploy them out, can actually communicate backwards and communicate to that central logging platform. Do you have things like the config set up and ready to go? Have you kind of determined how you're going to do things like ship the logs from the endpoint back out to wherever that central log aggregator is as well? So doing things like having infrastructure built is a challenge, because not all the time do you know what infrastructure this is going to go on. You kind of want this ready to go and ready to basically package up and just give to a client and go, all right, we need you to push this all out, and so that we can start getting some visibility on the end environment. And then this kind of also leads to things like testing and making sure that what you've actually built will work for a client, because you might not know what that client actually has on their side. So, I mean, I've seen cases from everything as nice as things like Server 2016 fully patched with Windows 10 fully patched, even some recent Server 2019 deployments, which is really nice to kind of see as an investigator. But then I've also worked on cases where you have things like really old versions of like Server 2003, which are no longer supported, and being able to understand whether what you're about to give the client is actually going to work correctly. So a lot of the time, again, this challenge is around actually taking what you've kind of built as a generic build to work in this type of environment, and doing things like actually testing these in multiple VMs. What we actually did as part of this is we actually did things like spin up multiple versions of the Windows desktop. So we kind of spun up everything from Windows XP all the way through to Windows 10 to actually find out what are the little nuances or the little things that don't work as part of this, and where does things like osquery and the way that we're shipping logs back actually just completely fall over, and we kind of have to go, look, if you've got this type of endpoint, it's actually not going to work. Because again, you don't want to get into this mode of kind of giving it to the client and going, oh, let me just test that a little bit differently and alter that. Because at that point, you're kind of letting the threat actor continue to move or continue to roam in the environment kind of unchecked as part of that. And then the bigger challenge, which is probably more of a challenge based on where we are as sort of a global issue at the moment, in terms of a lot of people working remotely. And I mean, this has been a challenge for the majority of last year, and probably will continue to be a challenge going forward, at least for this year and maybe even the couple of years after that. And that's where we have things like remote workers. So it's no longer that we have these endpoints sitting inside an environment connected to the Ethernet or the LAN or whatever it might be that continually stays connected there. It's no longer that we have those systems sitting there, or at least that they end up on that LAN on a pretty regular interval. Now we have a lot of systems sitting remotely. And you might kind of go, well, that's all well and good, but we've got things like VPNs, which people connect to. And that's true, we do. I've seen lots of organizations that have VPN set up so that people can connect back into their environments. But more often than not, in a lot of the cases that we're seeing now, is that these remote workers don't often have to connect back into the VPN unless they're doing some type of very specialized job. So it might be the case for someone like for HR or payroll or legal type departments, where they do have to regularly VPN back into an environment to access either proprietary software that they're using as part of their work. But when we see sort of people like developers or graphic design people that will often not need to regularly connect to the VPN, they'll do things like just work with cloud services. So they might be just working with things like G Suite, which doesn't require a VPN connection, or Office 365, or any of those types of cloud-based suites where they no longer need to actually actively VPN back in. Now, I mentioned this as probably one of the larger challenges that we see at the moment, and that's because it means that we can't often do things like just rely on everyone actually being on the LAN at some point in time. It's kind of like that LAN no longer exists. So in terms of solving that from sort of an osquery and telemetry and being able to use this type of tooling is not too hard. Like the concept of around saying, all right, we'll hold the logging platform out in the cloud somewhere so that we can access it as investigators. Perfect. We'll set up log shipping that will ship the logs from the osquery agents up to that location, and we'll figure out a means to do that. Okay, that's all well and good. But then actually deploying that in sort of anger or rapid fire becomes a pretty big challenge at that point, because how you would typically kind of deploy this stuff out is you do things like you could push a GPO policy out, or we see some environments who have sort of internal scripting set up as from their domain controllers. And again, that's all well and good if someone's actually connected directly into the domain controller, which require them to be on the LAN or would require them to VPN in. So this is probably one of the larger challenges we see in trying to use osquery in this manner. And that is just because around getting the agent actually deployed to endpoints now is probably one of the biggest struggles we see. Now, some organizations have done well to deal with this. Some organizations have their own software deployment tools, which connects through the internet and doesn't actually require VPN, which is all perfect. But to be honest, that's probably a small few of the clients that we actually see that have that capability. And I think probably, particularly in the consulting space, I think the reality around a lot of that is that if people have sort of this strong architecture set up, it's probably rare that they probably reach out to consultants to assist them with incident response, because they often are a lot more mature to start with. So the challenge is around how do we actually help these organizations which are less mature be able to use something like osquery, which is highly mature as part of that. Now, to set this all in perspective, now that we sort of understand what these challenges are, the reality of how we actually see things like an engagement kind of work and where we actually can kind of inject things like osquery into the concept of being able to do incident response looks a little bit like this. So let's assume for a minute that a client has an incident. Now, as I said, that could be anything from days all the way through to months that has occurred in the past before they actually detect or actually understand what's going on. Again, a lot of the statistics that are published annually by various sort of different vendors and different research papers kind of shows that is the case, and probably will be the case for quite a while. So we could be anywhere between days to months in terms of detection between when the incident occurred and when the victim actually knows about it. Now, from that point, clients, from what I see, often takes them anywhere between sort of a few hours to days. Now, the average is probably about 2 days between when a victim actually detects that they've got an issue and when they actually would engage a consultant as part of that. And that can be for a number of reasons. That can be to deal with things like contract T's and C's, and can deal with lawyers arguing about contracts either side, getting contracts signed, negotiating price, etc. All those things kind of play into that time as part of that. The reason I mention that is because this is important to understand how far back in the past an incident has occurred and what things like osquery will actually give us the capability to do after that incident has actually occurred as part of it. So on average, about 2 days before a consultant's probably engaged. If it's quicker, that's always good, but the average is about 2 days. And then in terms of once you've actually been engaged and then starting to actually do the rollout of something like osquery, we see that, again, be about an average of 2 days as well. Now, some organizations are well and truly across how to do remote deployments and software deployments, and that's brilliant. We've also seen organizations who really struggle with software deployments as well because they haven't done one in forever, or they're pretty laxed in terms of actually maintaining software or pushing out software to their end users. So on average, it's about 2 days from the point of where we kind of go, all right, here's the package of what we need you to get pushed out to all your endpoints, which contains things like osquery, the log shippers, and the config information. And here's that package. We need you to push that out and actually get that to execute and install on the endpoints, and we give them instructions on how to do that. Now, more often than not, in a lot of the cases that we're kind of seeing, this is done predominantly with things like group policy deployments, which is good. That makes it nice and simple for us to do. But again, we're back in this world of having issues of end users who are working remotely now, who may not connect to a VPN for weeks at a time. So that kind of ends up as that challenge. But in terms of actually getting to the end victim and actually getting them to put it somewhere so that it actually starts to push out, it's about 2 days. And then from there, in terms of that getting rolled out to those endpoints and investigations starting, that basically comes down to a couple of hours, because once you start to get that rolled out, you actually start to get telemetry of what has occurred as part of that, and you can actually do some investigation. And then to kind of round this out completely, it's probably about 4 weeks for the investigation on average, and then you would do things like pull osquery out of the environment as part of it. Now, again, you got to remember that at the point where this becomes useful to me as an investigator is around here where osquery actually gets rolled out. Because it's not until this point that I actually start to see telemetry of what's actually going on with an endpoint. So, yes, I do have things like the ability to query things. I do have the ability to query some evidence that has occurred inside of data that still sits on an endpoint with osquery, which is perfect. But it's pretty much from this point onwards I start to see really high visibility data with osquery. The challenge that we've seen though with this type of deployment is in cases like ransomware cases, we've seen malware variants of ransomware actually blow away a lot of our useful telemetry. So even things like prefetch files, like we've seen cases where prefetch files are just completely blown away as part of it, or where or other things too. I mean, volume shadow copies is a common one, although osquery doesn't do a lot with that at the moment. But we often see adversaries kind of destroy a lot of our evidence at this point in time. So think about even something simple like just querying timestamps on files. Now, that's enormously useful to me as an investigator, because I want to know the time at what certain things occurred or what certain files or artifacts landed on an endpoint. If there are things like malware which ends up on an endpoint, or potentially sort of this sort of huge bucket of files or huge folder of files that has been zipped or RAR'd up to basically attempt to exfil data, I want to know things like when that was created, when it was last modified, so I kind of have the time of when these things occurred, or even folders that an adversary has created or files that the adversary has created, so that I know roughly at what times that they were doing certain things and how long they've been on those endpoints. When we see things like ransomware, they tend to kind of destroy a lot of those artifacts as part of that, and kind of only leave us with very limited timestamps that haven't been altered as part of the actual encryption process when we see things like ransomware. Now, in a normal environment, osquery being pushed out, I would have a lot of that historical data if I was taking snapshots of that information and then storing it. But when we end up at the point where the incident has occurred sort of multiple months and a number of days in the past, things like that information is lost on us. So you kind of need to understand that even though I'm pushing something like osquery out at this point, there is a quantity of data that I've lost. And the reality is this is no different to what you would see with any other type of EDR system either. Like we would still have EDR systems doing things like querying the MFT files on Windows to actually try to determine timestamps. But I mean, if we were to do things like open up volume shadow copies, then you might start to see something interesting. Again, like with ransomware, we see volume shadow copies more often than not kind of destroyed as part of that process. So some of the other big investigation challenges that we see to be aware of, at least if you kind of use osquery in this way. So the first one is a big one. This is around preservation of evidence. Now, it's not uncommon for as part of an investigation that you might be doing on a consulting perspective, where you might come in with all intentions of going, all right, this is just a pretty stock standard incident. The end user or victim has been compromised, and we need to sort of get them back to working to normal and understand how the threat actor got in so that doesn't happen again to them. But there are times where we see cases move from this incident response type process into this legal process where we go, you know what, we've kind of got enough evidence here which kind of points to a potential individual who may have actually initiated this inside the organization. And then it kind of moves into this legal perspective of, okay, what happens if we want to actually prosecute this person through law enforcement, or what happens if we want to actually take this person to court or something along those lines? And at that point, when an investigation moves to that perspective, we end up needing to do things like preserve evidence as well. Now, preservation of evidence kind of has this scale that varies between collecting the evidence so that you can do simple things like write a report at the end of it and make sure that someone else can kind of cross-check how you determined a finding, all the way through to, all right, we need to preserve this type of evidence so that it can be looked at by opposing counsel if we're actually going to do things like prosecution or run this through the courts. And in those cases, this becomes sort of this interesting challenge. Now, I think like osquery has gotten better at doing this over time. We've got the ability to do things like carve individual files out, which is really nice. But when we want to do this at scale with large amounts of evidence is where we start to see challenges with this. It's not uncommon where we might go, all right, we want to go and pull back all of the enter_user.dat files for every user from every endpoint as part of evidence that we need to keep because there's something highly important inside there that we need to hold as part of evidence so that opposing counsel can look at that later on or their experts can look at that later on. Now, doing that on a single system with osquery, perfect. We can use things like carve feature to go and suck that out. That's nice. But doing this at scale with every user account that's on every system starts to be a bit of a challenge. Now, there are ways you can do this and start to script this up, but that's kind of a very ad hoc method of doing that. So it's one of kind of the interesting challenges we've seen with using osquery at scale. And to be honest with you, this was even an issue with using osquery internally inside organizations where if we wanted to kind of target a group of systems or a particular type of evidence that we needed to actually retrieve from an endpoint, this can be a bit of a challenge in actually doing that. So this is kind of one of the areas that we kind of hope to see osquery kind of develop further in this space a little bit more. But understand it is also a challenge for other EDR tools as well. I mean, I looked at a number of different EDR tools when I was internal, and this was still a challenge trying to go, all right, I want the enter_user.dat file from every user account on this sort of group of systems, and I want that now, as opposed to let's go through and manually pull those apart. So that's one of the challenges we kind of face with using osquery in this way. The other one, which is I think a little bit more of a fundamental issue with around how osquery is intended to be used and how it's kind of being bent to be used at the moment. So osquery is brilliant for doing sort of wide sweeping and looking at systems, which is great. But it's been interesting. There's been a couple of cases that we've kind of come up against, which are more insider threat type cases that actually require us to look fairly deep into a system or actually look very specifically at user behavior on a system as well. Now, I spent a little while, we actually spent a while trying to actually get osquery to do this for us and ended up with sort of understanding that this is not originally what osquery was intended to do. But I am conscious that osquery has sort of this privacy consciousness to it around a lot of the development has been around not specifically trying to expose too much of the privacy information that individual users may actually be doing on a system. The only challenge that at least I've come across in doing that is that if we have someone like an insider threat, so let's say we have an insider threat who's using an anonymous type email service or an anonymous file drop service, where essentially they're using that to either exfil data out of the environment or using that to communicate out of the environment that they're inside of. A lot of the times, to go looking for that type of information on the endpoint, we do things like go looking through cookie data, or we'd go looking through web browser history or bookmarks on inside the web browser. Is kind of like the common or simplest ways to go looking for those. And I'm talking specifically here just about the endpoint, because remember, from a consulting perspective, I might not get engaged until this incident has already occurred well into the past as part of it. So I don't have the advantage of being able to do things like deploy network-based telemetry to actually look at what's going on the network. So I've got things like osquery which sit on the endpoint that allow me to then interrogate it. But this has kind of been this sort of interesting challenge where we've faced some of these insider threat cases where we can't actually use things like osquery to dive into some of that very sort of user-centric or that personal user data to actually pull things out, even though the user data may be related to a malicious insider. We've still got this challenge at the moment where osquery doesn't fully do that. Some of the ways that we've kind of gotten around that for now, this actually goes back to the first point I have on here, is we'll do things like actually collect the files that relate to those artifacts and pull them off the system and then actually run parsers across them later on. The problem with that, though, is that at that point, I've essentially got to pull all that data off and then get it out and then parse it with another system. Whereas if I had things like osquery, I'd rather sort of leave my investigators all inside one platform to kind of do that that type of searching. So that's one of the challenges. There is kind of that way around it, around pulling the evidence and then parsing it later. But the reality is I kind of want to get all that data in that one central system as part of it so that I don't have to spend lots of time kind of parsing those artifacts later on. The other one, which kind of then goes back to relating around understanding what it is that we want to capture to start with, is understanding the configuration of how I want things like osquery set up. So things like shipping the logs outbound doesn't change too much. But what does change is you might kind of change around if you're doing things like snapshotting some of the tables which aren't evented tables. If you actually want to snapshot those tables which aren't part of the evented tables and you want to kind of ship those out of the environment, the requirements for those might change, and actually doing things like changing the config that sits alongside of osquery actually becomes pretty challenging when you're running it in this manner, because a lot of the times, remember, as I said before, it can take kind of on average 2 days before the client or the victim can actually push out the config. And I don't want it to take, or push out the osquery package. I don't want it to take another 2 days before they can push out an updated config file to all the endpoints and then hope that they kind of check into the domain controllers and hope that they pull down the GPO while they're connected to the VPN, because most of the users nowadays are all sitting remotely. So doing things like altering the configuration post-deployment is one of the challenges that we kind of see at the moment. It's not something that is at this stage kind of easily fixed. Like there are kind of other, you could use something like, if you had something like upticks, which will allow you to do that. But this is kind of one of the challenges where sort of the pure osquery component kind of struggles a little bit. And I'm kind of hopeful that at least the basis of osquery will allow us to make those changes over time. And the reason I kind of say that is because a lot of the other tooling in the same space as sort of osquery already kind of allows for that. So if I was pushing another commercial EDR tool out, I would be able to easily change the config on the fly or change this capturing kind of on the fly and be able to kind of alter that. So this is probably one of the challenges that we see with osquery. If you kind of need to alter that configuration post-deployment, you will start to stumble a little bit if you're kind of using it in this manner. The next one around this is longevity of the use of osquery. Now, it's not uncommon that in a consulting manner, you might actually, again, do the investigation, use a tool like osquery and push it out and be able to investigate really quickly. It's not uncommon that the client might actually come to you and go, look, this is really good that you've pushed this out and we can kind of see that you guys have managed to sort of investigate things really quickly. Could you actually leave that there and can we kind of hold on to it and continue to use it afterwards? Now, from a consulting side, that is a huge plus. And it's got absolutely nothing to do with, osquery being the sort of open source tool it is, there's no money exchange or no sort of financial benefit to doing that from a consulting perspective, but there is huge benefit in terms of visibility for that client, and that's something that I always love leaving a client with is that they have increased their defense mechanisms, or at least increase their ability to try to defend their network in the future. So if they can do that, that's something I want to leave that client with, so that the next time this happens, they can do this much faster, or they can implement detection rules around trying to detect the same type of attack that we've just uncovered inside their environment. But the challenge that we've kind of seen at the moment is that when we do things like have a centralized logger, which we might hold as the investigators doing the work, and then when we do things like push out a config file and have the log shippers, which ship the logs out to the log aggregator, which we control, handing that over to the end client becomes a little bit hard. And it's not impossible. A lot of the times what this usually results in is a change to the config and how log files are shipped, and setting up the an internal logging instance for the client as part of that, which is all really good. But the time in doing that and getting things like the config files re-pushed back out again is challenging for a lot of clients who are basically victims to a lot of these attacks. So that's kind of one of the challenges we're seeing. I think from a lot of the cases that I've worked on where we've had clients ask for this to sort of stay inside their environment, I think the way to kind of easily solve this is we've been able to do things like push configs out or be able to push things like the log shipping tools that you're using back out to that endpoint quicker. Now, relying on the client to do that is not always the best approach, just because it can often be a challenge for them to even push software out to begin with. But being able to do things like, if we can do things like leverage osquery in some way to be able to do things like update some of its own config files or update some of its own binaries that are sitting alongside of it, that will actually make this much quicker as part of doing that. Now, again, this kind of breaks some of the rules of osquery around altering items on a system, which I appreciate as well. But it's these challenges which will ultimately make defense a lot better for a lot of the victims that we're seeing, so they can kind of continue to use these tools later on. All right, so what are some of the big takeaways, or the things that you should be aware of if you want to go and use osquery in this way? And I strongly encourage people to do this. I'm a big fan of osquery. As I said, I've used this internal, and I've tried to sort of drag this along with me in doing consulting and be able to do this the same way, so that a lot of the victims and a lot of organizations get the same benefit that I've kind of seen internal organizations use with it. So some of the big takeaways, probably the biggest one is around remote data collection. Now, you might kind of go, oh yeah, remote data collection, that all kind of makes sense. But think of this from the perspective of how you use tooling and telemetry on endpoints or on systems inside your environment. One of the largest challenges that I always saw with EDR tools, whether they be other sort of open source or sort of roll your own type tools, or whether they be commercial tools, is a lot of those tools do things like rely on the data sitting on the endpoint. I mean, even to a degree, that's kind of what osquery is doing until you ship the data out of the endpoint. But a lot of the commercial tools would do things like rely on querying live systems with data that's sitting remotely on that endpoint. The challenge around this is, again, it relies on things like users actively being online to start with. So if their endpoint is not online, not connected to the internet or connected to some type of connection that you can query with whatever EDR tool you're using, if those endpoints are offline, and maybe one of those endpoints is patient zero that you actually want to get back to, and you try to query it with a lot of the commercial EDR tools, you won't see that data. And the challenge around this is basically quantity of data. A lot of commercial tools are doing things like relying on the endpoints being online and relying on the endpoints holding that data for a period of time, so that you can query all the endpoints remotely to sort of save on this issue of holding data centrally in one place. And the big benefit to osquery is that you can do things like ship that data out and query that centrally. And then at that point, it doesn't matter if the endpoint is online or not. Like if the endpoint's currently offline, but it's been shipping data for sort of the last couple of hours, and you want to look at what occurred a day ago, you can do that if all that data is centrally aggregated somewhere together. The only thing I kind of caution everyone on is making sure that when you do this, that you kind of realize whether you're doing this internally or whether you're doing this as part of a consulting type arrangement or doing this with acquisitions, is that you hold data for a kind of the longest period of time that you think an incident may have occurred, or at least the average time that it takes between an incident occurring and you to detect that. Now, if that is kind of 50 plus days, maybe you should be holding that data for 50 plus days, or holding kind of key data related to that for approximately 50 days. But just remember that if you're aging this data out after 7 days or after 2 days, some of the really useful information that you actually need to query to kind of go back and look historically may not be there as part of that. But either way, the getting data off an endpoint and being able to query that in a centralized location is a huge benefit. And that's probably one of the biggest benefits if you're using osquery in the fashion of where you're basically shipping the data back to a central location, that it that it always kind of outperforms a lot of the commercial EDR tools, at least a lot of the ones that I've seen. The other one is things like evented tables are most definitely your friend when it comes to an incident. And that's because at the point where you're coming from this sort of consulting perspective, you're looking at a live incident that's already in flight, that's already occurring. You've already got the threat actor inside the environment. So evented tables are most definitely your friend when it comes to trying to actually understand what's going on live on individual systems, because you don't have the benefit of looking historically backwards in time if you've just pushed out the config as part of it. So one of the key things we do as part of this is we'll do things like set up rules related to the evented tables to actually go looking for unusual behavior. So if we start to see things like PowerShell spawning other things like scheduled tasks, or PowerShell being spawned by things like WMI, then those things are highly interesting because they don't often occur inside the environment. And evented tables pick up that type of activity. So use the evented tables to your advantage. That's probably one of the first things we start to look at when we get osquery inside an environment, because we can actually start to see a live picture of what's actually going on inside the environment. The other one is Yara. Now, Yara is probably is probably key to uncovering a lot of the historical TTPs that we look for. So evented tables is kind of my go-to for finding out what's going on in the system now and trying to detect the adversary in the environment right now. Yara is more often than not what I use once we've uncovered investigation, and then we actually want to look at where else the threat actor has been. So if we know that the tools that they're using are a certain type of tool set or a certain type of files, or they're leaving kind of certain types of traces on the environment, we'll often craft Yara SIGs and then use that to actually track where the adversary has been historically. Because remember, osquery is getting pushed in after the incident's already occurred. So we start to use things like Yara to actually go historically searching with osquery to go looking what's occurring. And then also at that point, we'll also use Yara to kind of do future looking at where they kind of move or pivot inside the environment. But more often than not, the evented tables, even the Yara evented tables kind of end up as the key items that we tend to use for a lot of those. So if you kind of want to look backwards in time, once you've got some of those TTPs or those tactics, tools, and procedures that the threat actor is using, start to use Yara SIGs to actually look backwards in time, because remember, you don't have the benefit of osquery being sitting there for months beforehand to actually go backwards and looking. And the other big benefit to using things like osquery in this manner is it is cross-platform. So it means that I can basically take this and use this in a Linux server environment as well as a Windows desktop environment as part of that. And that is a huge benefit. Also, the power of osquery is much the same regardless of what platform you're on. Sure, there are slightly different tables for different types of artifacts. That's kind of a given. They're different operating systems. But even simple things like if I want to use Yara for historically looking back, and I want to look back at certain artifacts that have been dropped on endpoints, regardless of whether it's a Mac, a Linux server, or and particularly inside of AWS environments where most people are using Linux nowadays, it doesn't really matter whether it's Mac, Windows, or Linux. I can use the same type of searching techniques, and the operators or the investigators who are using osquery don't have to kind of learn different types of terminology to do this sort of simple look back task with things like Yara. And that's probably the strongest takeaway and why I've kind of stuck with osquery for so long as part of doing this. Now, I know that's kind of very quick and probably a very sort of large overview. So you're more than welcome to kind of ask questions or shoot me questions later on. I know some people won't be keen to kind of ask questions live, and that's perfectly okay. But if you've got kind of questions or other things that you don't want to ask in sort of an open or in this sort of public forum, you're more than welcome to shoot me an email or hit me up on Twitter or LinkedIn as well. And I'm more than happy to kind of have those conversations separately as well. But either way, thank you all very much for listening to my session today. It's great to be able to kind of share this type of information with everyone. And if there's anything that you're kind of doing that's different as well, then by all means, hit me up on Twitter or LinkedIn, or shoot me an email as well. But by no means at all am I saying that the way that we're kind of using osquery in this fashion is the correct way to do it. A lot of this has been a little bit of sort of 2 steps forward, 1 step backwards in terms of figuring out how to use osquery in this consulting fashion. But the big benefit that I wanted to bring to this was to basically take the power of what I've seen osquery do inside an environment and actually pull that over to kind of the consulting space and to try and help other organizations, and where it works best, try and leave that with organizations so they can kind of better defend themselves into the future. So anyway, thank you very much for listening to my session. I hope you enjoyed it. As always, shoot me questions right at the end of this, or shoot me a note afterwards as well. More than happy to kind of continue to discuss it further. Other than that, thank you all very much.